Periodic functions, part 1. Each of the following problems describes a situation which can be modeled by a periodic function. For each, sketch a possible graph of the periodic function. Try to give accurate coordinates for the minima and maxima, but don't worry too much about the shape of the graph between them. 2, estimate the period, midline, and amplitude of the periodic function. A. The temperature of a chemical reaction oscillates between a low of 30 degrees Celsius and a high of 110 degrees Celsius. The temperature is at its highest point now and completes one cycle over a 5-hour period. Sketch the temperature T against the time little t over a 10-hour period. Okay, little t is down here. Capital T for temperature is over here. We're trying to go over 10 hours, so we'll put this here. Midway is 5. And let's use the fact that there's a 5-hour period. I always like to take the period and divide it into 4 because there are 4 natural pieces of one cycle for the functions that we're thinking about here. So 5/4, which is 1.25. So if we go to the middle, it's a 2.5. Middle again is 1.25. Middle over here is 3.75. So it's just 1.25 for every step. And then you can do the same thing over on this side. 6.25, 7.5, 8.75, and finally up at 10. So we're done with the period. It says the max temperature is at 110. So let's go ahead and say that that 110 is up here someplace, and maybe we can go by like 25s or something. So maybe I won't put 110. We'll go by 25s. So 110 will be a little bit higher than that top one there. And it says it's that it says highest point right now, and the highest point is up at 110, and right now is at t equals 0. So we start there. And then it gets to a low of 30 degrees, and then back again after 5 hours. So I guess I can put that point there. And then we want to figure out, let's see where the low is. So the low is 30, so that's maybe somewhere around here. And then halfway seems to be an important number. So what if we do halfway between 110 and 30? So add them up and divide by 2, just finding the average. So it seems like 70 is the middle. In fact, that's going to be the midline for us. So we started at 110 right now, and then the next time period that's important is 1.25, and we must be at the middle at that point. And then after the next time period, 2.5 hours, we're at the bottom, and the next time period back at the middle, and then the next time period is up at the end. Maybe that's a little bit high, so we'll put it somewhere around there. And then it repeats, so we'll just do the same kind of thing. So it starts at the high, it goes middle, low, middle again, and then high. And you don't need to worry too much about how it looks, but again, you probably should avoid just drawing straight lines through all these things. It's generally not how stuff works. So make something that's kind of curvy, try to make something smooth that hits or is close to hitting all of those points. Okay, so we want to find the period. So the period here is how long it takes to cycle, 5 hours. The midline, remember we don't want just a number, but we want an equation. So y equals, or maybe capital T equals, and the midline we found was 70 in this case. And we'll know that we got the midline right if we check on the amplitude, because it should be the same number to go from 70 to the top as it is to go from 70 to the bottom. So if we go from 70 up to 110, we get 40, that's the amplitude, versus going from the bottom up to the middle, still 40. So the amplitude is 40. B. The amount of daylight varies over the course of the year. The summer solstice, June 21 this year, is the longest day of the year in Greenfield. It's the longest day of the year. In Greenfield, there will be 15 hours and 18 minutes of daylight. The winter solstice, December 21st this year, is the shortest day. In Greenfield, there will be 9 hours and 5 minutes of daylight. Sketch the length of the day in hours, d, against the time, t, over a 3-year period. Okay, so let's give this a shot. So let's see, against time. Okay, so we can define 0 to be anything we want. It's kind of natural to define 0 to be January 1st, but actually it's going to be easier for us to define 0 to be one of these two important dates. So how about we just call 0 December 21st? It's just going to make our lives a little bit easier. Okay, so t equals 0 is December 21st. And so if we come back out here to 3 years from now, if we wanted to, we could think of this in terms of, let's see, against the time. So we could think of t as measuring in days or months or years. Any unit is fine for time. I'm going to go ahead and call it, let's call it months. So 3 years from now would be 36 months. And so I guess that means that that's December 21st, but 3 years down the road. So I've got 3 years here. I'm going to cut this into 3 roughly equal pieces. So there's 12 months in after the first year, 24 months in after the second year. Okay, and then it says the maximum temperature is up there at 15, the minimum is at 9. So how about we say that 15 is right up there, and then we can maybe go by 5s. So there's 5 and there's 10. And let's go ahead and calculate these numbers in terms of hours instead of hours and minutes. So 18 minutes, let's see, both go into 60, 3/20ths, which is, what is that, 0.15. So what we should be at is 15 hours and 15 minutes, which is going to represent, or be represented by 15.15 hours, if I've done that right. Okay, so 15.15 hours, and then we can do the same thing for the 9 hours and 5 minutes. So that's going to be 9 point, and then 5/60ths. I'm just going to type this into the calculator. So 0.08 and change. So I guess those are the numbers that should be highlighted on our vertical axis. So 15.15 we'll say is up here. And then 9.083 maybe there. And it sure feels like we need to know the middle as well. So let's use a calculator to help us find the middle. It should be something right around 12, but we can get a little bit more accuracy here. So make sure that we did that right before. 18/60ths is not 0.15. What did I do wrong there? Oh, it's 3/10. It's not 3/20. You guys got to stop me when I do stupid stuff. Okay, so let's fix all this. Okay, so that's 3/10. Let's try again. That's 3/10, which is 15.3. And so then out here, you can say that it's 15.3 is the important number. And I think that's good. We'll erase this and make it 0.3. Okay, so I think that's fine. And then we said we wanted to find the middle. So let's average these two numbers here. So we are doing 15 plus, or just 15.3. And then plus the 9 and the 5/60ths. So we get that, and divide by 2 to find the middle. We set around 12, so let's call it 12.2 for this one. So 12.2 is maybe here. Okay, and so we've got our important vertical numbers. I guess we don't quite have the important horizontal ones yet. So in terms of the important horizontal ones, what do we have here? Let's see. So 12 months is one cycle. Remember I said I like to take the period and divide it into 4 pieces every time? period divided by 4, which is 12 months divided by 4, which is 3 months. Makes sense? That's what we call a quarter of a year. It's 3 months. So if we go to 6 and then 3 and then 9, those are the 4 quarters of our year. And December 21st, let's see, where do we start at December 21st? Well, it says it's 9 hours and 5 minutes. It's the winter solstice, so we start down there. And then 3 months in, I guess we're at the middle. And then 6 months in, we're at the high. Does that make sense? December to June, 6 months. Okay, so that works out. And then another 3 months in, and we're back at the middle. And then another 12 months from now, which is December 21st, a year from now, we're back at the bottom. And then it repeats. Next one is at the middle, and the top, and the middle, and the bottom. And then one more time, middle, top, middle, and then bottom. And again, just try to connect them with some kind of a smooth curve. It's not going to be perfect. But that's it. And now we'll just write down the other things they asked for. The period is how long it takes to do one cycle. 1 year, or 12 months, or 365 days. Period depends on what unit you use for time. Next one we wanted was the midline. I think we've already found it. And we found it by taking the 15.3 and adding the 9.083. That was the high and the low, and dividing by 2. And so we got something around 12.2 for that one. And the amplitude is just how far it is up or down from the middle. Oh, I broke my cardinal rule. I said that this has to be an equation, not just a number. So then equation here would be, I think we called it capital D for daylight. So the midline is capital D equals, it's a horizontal line at about 12.2. And then the amplitude is the top number, 15.3, minus the middle, 12.2, and we get there 3.1. Notice that we'd get the same thing if we did the middle minus the low.